Speed and velocity. So first, let's talk about the average speed. Average speed, we use a symbol S, which is describe the total distance traveled by an object divided by the elapsed time to cover that distance. Or in symbol, we have S is equal to D over time. Okay, so let's suppose we have an object or a car moves 30 meters within, let's say, 10 seconds. Therefore, the average speed of that object is, by dividing it, we have 3 meters per seconds. Or let's say we have, okay, let's say an object moves 150 feet within, let's say, 5 hours. Therefore, its average speed, dividing it, 150 by 5 is 30 feet per seconds. So let's consider this example problem. So how far does a jogger run in 1.5 hours if his average speed is 2.22 meters per second? So we have our given, let's state the given, time which is 1.5 hour, and average speed of 2.22 meter per second. So using the formula, speed is equal to distance over time, or distance is equal to average speed times time. So using this formula, let's substitute the given. So we have speed of 2.22 meter per second times 1.5 hour. So the unit for distance must be in meter. So we have to eliminate the unit of time, which is a second and hour. To do that, let's convert 1.5 hour into seconds, which 1 hour is equal to 3,600 seconds. So using this, let's perform the operation. We cancel out seconds and hour. Therefore, our distance is, use your calculator to compute for this one. So we have 11,988 meter. So don't forget your unit in solving or in finalizing your answer. So now, let's talk about average velocity. So unlike speed, average velocity describe the displacement or how fast the displacement change or its position change. So the symbol for velocity is V, which is equal to displacement. And like displacement, velocity is a vector quantity. Therefore, direction is important to be indicated. So we have displacement is equal to final position minus initial position, where elapsed time is final time minus initial time, which is equal to delta x over delta t. So let's say we have an object moves from position 2 meter from an tree, then moves farther. Let's move 5 meter away from the tree. Therefore, it has a displacement of 3 meter within, let's say, 1 seconds. Therefore, its average velocity is 3 meter per seconds. Okay, so let's consider this example. So we have here a car is testing its speed, and to do that, he make 2 runs throughout the course. So in the first figure, it shows that the car first travels from left to the right and covers a distance of 1,609 meters within 4.74 seconds. Then it travels from right to left, covering the same distance within 4.695 seconds. So the problem is, what is the average velocity of each run? So let's solve for first figure. So we have the displacement of 1,609 meter. And we have the change in time, which is 4.740 seconds minus 0. So again, it is important to indicate which direction you will set as your positive direction. And in this case, the direction to the right is our positive direction. Therefore, we're going to have a displacement of positive. So now let's solve for the velocity. The average velocity is equal to displacement, which is 1,609 meter, divided by the elapsed time of 4.74 seconds. Therefore, the average velocity is, use your calculator to compute for this one, 339.45 meter per seconds. For the second figure, we have displacement of negative 1,609 meter. Why negative? Since our positive direction is to the right, and the direction this time of the car is going to the left, therefore we're going to have a displacement of negative. And again, the elapsed time is 4.695 minus the initial time, which is 0. So we're going to have elapsed time of 4.695 seconds. And using the formula for average velocity, we have negative 1,609 meter divided by 4.695 seconds. Therefore, we're going to have a average velocity of 342.70 meter per seconds. Sorry, it should be negative 342.7 meter per seconds. So meaning, if your displacement is directed to the positive direction, therefore you're going to have and velocity of positive. Otherwise, if the displacement is directed to the negative direction, therefore your velocity will be negative. So now, let's try to represent the velocity using a graph. So let's have a position and time graph where y-axis will be our position with a unit of meter or any unit depend on the problem. So let's just take away the let's just remove the meter, and the x-axis is time. So let's represent the position with a curve. Okay, let's say like that. So this graph does not represent the track of an object take in the space. Instead, it just represents its position at every time, or with respect to time. Okay, so let's say we have here initial position, let's say PO, and we have a final position, let's say here PF. So the initial position, so the time for final position is TO, or T sub O, or T naught, and time for final position is T sub F, or final position, or final time, sorry. And its corresponding position is this one, which is X naught for initial position and final position XF. So our velocity is from initial position to its final position. So you can see here that we have formed a right triangle where the two legs represent the change in position. So here is the change in position. And the change in time. So a change in position is xf minus x naught, and change in time is pf minus t naught. And we have here the velocity, which is the hypotenuse. So using this triangle, we can solve for velocity by finding its slope. So slope, as defined, is equal to rise over run. And based on the figure on the triangle, our rise is the change in position or the displacement, and the run is the change in time or the elapsed time, which is equal to velocity. Therefore, slope of this triangle is equal to velocity. which is equal to delta x over delta time. Okay, so now let's have another example. Starting from a pillar, you run 200 meter the x direction at an average speed of 5 meter per second. Then run 280 meter west at an average speed of 4 meter per second to a post. Calculate A, your average speed from pillar to post, and B, your average velocity from pillar to post. So in every problem such as this, it's important that we have able to illustrate our problem. So we could have able to visualize the scenario. Also, we can analyze the problem more easily. So we have here a pillar. Say, let's say this is our pillar. And starting from pillar, meaning this is your initial position at time 0. You run 200 meter east. This is 200 meter at an average speed of 5 meter per second. Let's say this V1. We have here this. Okay. And then you run 280 meter west at an average speed of 4 meter per second to a post. Okay, so meaning after you run 200 meter to the east, you run another 280 meter, and this time going to the west, and stop in a post. Which is equal to, okay, let's erase this time, 280 meter at a speed, average speed of 4 meter per seconds. Okay, so our problem, letter A, find the average speed from pillar to post. And letter B, the average velocity from pillar to post. Okay, so let's solve for our problem. So first problem, average speed from pillar to post. So you can see here, you have traveled 200 meter from pillar, going to point X1, then going to the west, which is 280 meter to point X2 or the post. Therefore, you have a distance traveled of 200 meter plus 280 meter equal to 480 meter. So now, what is your total time it takes to travel? So we have to solve for T1 and T2. So T1 represents the first velocity, first speed. To solve for T1, using distance formula, we have distance over speed. So T1 is 200 meter divided by 5 meter per second. Therefore, you have 40 seconds. And T2, we have distance over speed, which is 280 meter divided by 4 meter per seconds. Therefore, you have a total time of 70 seconds. So your elapsed time traveling from pillar to fosse is 40 seconds plus 70 seconds, which is equal to 110 seconds. Therefore, your speed is 480 meter divided by 110 seconds, which is equal to 4.36 meter per seconds. This is your average speed. Now, for letter B, which is we're solving for average velocity from pillar to fosse. So the formula for average velocity is displacement over elapsed time to cover that displacement. And take note of this, our displacement is from initial position to its final position. And our final position is to the west of the pillar, which is negative 80 meter. Why negative? Because it's directed to the left, and we have said that the east is our positive direction. Therefore, we have velocity of displacement over change in time, which is equal to negative 80 over total time traveled is 110 seconds. Therefore, our average velocity is negative 0.73 meter per seconds. So now, let's check our understanding. Solve these two problems and comment your answer in the comment section.